Is day one of the observation project for first year seminar. And before I kind of get into the things, I just want to preface that this is going to be, since of course I cannot record my face, but you'll be able to hear my voice. What I've decided to do is I've decided to do a screen mirror of my computer screen so that I can show you what I'm talking about instead of just giving you a recording. I feel like that would be much easier. It's easier for the viewer to understand. Um, and so I'm going to try to make this video short and sweet, probably going to be about 5, maybe 7 minutes long, 5 7 minutes. Vary between that amount of time. Um, and so I am going to get all my things left here. And so the first thing I wanted to start with is how these videos are going to be like. And so I have a little video here by the guy I've been talking about, Dr. Levi Cowan. And so this was his video about Harvey. And I want to go choose the one that looks really scary and ominous. So yeah, you're invested. I'm just going to play a couple little seconds of his video, and just to get you an idea of how these videos will go for the rest of this week.
Day morning update on Tropical Storm Harvey in the Gulf of Mexico, which has unfortunately become organized quicker than anticipated. We had a large burst of convection which pulled the low-level center northward last night, and that convection quickly symmetrized about the center of circulation, such that we now have curved convective bursts developing and forming an eye wall around the center of the storm, and the system looks completely different than it looked yesterday, with an inner core now forming.
So yeah, I mean, as you can see, his video is only about 5 minutes long. And the reason I like this guy so much is he just gives a really good, short, informational videos, and they're very interesting, very good at what he does, and I'm very happy that he was able to get his doctorate, and now he is a doctor of meteorology, so that is very cool. So moving on to what I'm going to start with first is I'm just going to go to the National Weather Service page. I got to reload these pages because they're probably not up to date. And so mainly I just want to go over kind of the stuff, like what does all this stuff mean, and just kind of like the basics, starting with this week. And so really I do like the National Weather Service. They are probably the best source, and I don't really use the Weather Channel very much, and those other private websites, which, I mean, they're fine. They can be used. Usually they are very similar in their forecast, and they don't differ very much. I just like the format these guys use, and there's a lot of useful stuff that I'll get into later on. But starting with some of the stuff that's a little bit, it could be called common knowledge, but might as well explain it. Humidity. So starting with that, humidity is just the amount of water vapor in the atmosphere and the air, and so a high humidity, so humidity in the 80s and above, 80%, 90%, that means that the air is very moist, and you're probably going to see some rain. If the humidity is 100%, you probably had a rain shower. Usually the humidity is only 100% if you have seen rain or are about to see rain. Wind speed shouldn't be too difficult. It's just the wind magnitude in a certain direction. So right now in Houston at Pearland Regional Airport, which is the reporting center, it is northeast, coming out of the northeast at 9 miles per hour. And a lot of times, especially when we get into some more complicated stuff, you'll see miles per hour be in knots. And I have forgotten the conversion factor, but it's not very difficult to convert from miles per hour to knots. But it is kind of difficult to see it differently at first from miles per hour to knots. Barometer. So this is cool because this shows you the pressure, and a very good way to tell how the weather is going to be is what does the pressure say. Now, normal surface pressure is about 1,000. I want to say 1,016.15 millibars. So right now, Houston is about at normal surface pressure, and so that's good. That means that it's fair weather. The atmosphere is very stable, so that's very good. Gonna have a fair day. So that's kind of cool. The barometer is definitely, the pressure is something that I love to watch because it's so cool how it works, especially during hurricane season, which I'll get into in the video. Pressure is very important in determining the strength of systems, where a very low pressure, such as 950 millibars, denotes a very powerful low pressure system, and a very high pressure of about 1,032 millibars denotes a very strong high pressure system. Moving on to dew point. Dew point is basically the temperature at which, if it drops below this temperature, you will see dew. So if it gets, well, actually, I think if it hits this temperature, so if it hits 50 degrees or drops below 50 degrees, which it will not, you will see dew on the grass because the atmosphere cannot hold that moisture at that low temperature, and so it condensates into the liquid form of water vapor, which is just water. And so that's like a little cool tidbit. Visibility. Basically, the visibility, how far you can look to the horizon. So 10 miles, that's very good. Usually it's always 10 miles, that's the norm. And when you have a dense fog, you can see that cut down to 0.75 miles. And if you have just light fog, you can see that cut in half to maybe 5 miles. But visibility usually only gets bad, at least on the ground, with fog. Now, when you're in the airplane and in the sky, that changes drastically. There's much more to go on with that. But then the last update, not really much there. That's just they tell you they updated it at a certain time. Right now it's 11:39 p.m. and they last updated it at 10:53. And so I kind of opened up Corpus just to show you how Corpus differs. Corpus has a much lower humidity, and because of that, a little bit of a higher dew point. Same thing. Heat index. I can't believe I missed this. Apparently, Houston does not report the heat index, but Corpus does. And heat index is just telling you basically what is the feels like temperature. What is the usually heat index denotes what is the feels like temperature going up. We see wind chill, and wind chill just denotes with the wind factored in. Right now, the wind is 16 miles per hour. What does it really feel like? Apparently 81. And usually in Houston, especially in the summer, and probably in Corpus, you'll see heat indexes into the high 100s. 100, 203, those are pretty normal because humidity really boosts the temperature when you get enough of it, especially when you're in the 80% and 90% of humidity. Okay, and so that kind of, and then the forecast, I don't really think there's much to say here. Forecast 20% chance, that means that there's a 20% chance it will rain, there's an 80% chance it will not, so you probably take the higher chance. And usually I would say that anything above 40 is a good prediction that it's probably going to rain. Even if just a light sprinkle, 40 and above, and that happens later. I mean, we actually get a cold front, but I'll talk about that when we get to the prog chart section. Looking at some other resources, this is why I like to use the National Weather Service website over something like Weather Channel or IQ-Weather or Weather Underground. They give you these nice little layouts here where you can, let me just refresh this because it has not been refreshed, where it gives you this little map, and it just it helps you visualize it very well. And right here, this is just seasonal patterns. We are supposed to see a colder temperature weather, so below normal temperatures for both Houston and Corpus, only slightly though. You really see the colder temperatures over here, where you see that dark blue, and then poor California and Nevada and Arizona are going to see that really warm temperature. Precipitation also, Corpus, you guys are really in that. Kind of hard to see though. Gonna see probably some higher levels of precipitation than normal, and then Houston is kind of the same. And then drought, a little bit of drought down here, but hurricane season will probably wipe that away. Usually, Harvey at least did that, which was probably the only good effect of that storm. But so I want to move on now. Corpus usually has the same deal. Corpus has a cool little thing to where they show you when the front is coming through. And so Friday you get some storms in front, and then Saturday you get numerous because the front's coming through. And this front's going to stall out, and we'll talk about that again when we get to the prog charts. But one thing I want to talk about, which is very important, is before I get to the prog charts, is the GFS. So the GFS, I'm gonna be honest, I totally forgot what it stands for, but it is usually referred to as the American model. I think it's the Global Forecast System. I'm probably getting the S wrong, but I think GF means Global Forecast. And so what this model shows you is let's let me that one I like. Here we go. So this is the one, GFS, average precip rate. So more than just show you what the average rate of precipitation you're getting. It shows you where the weather's going to be. And so this 000 is the first thing I want to make sure I explain. That is Zulu time. Zulu time is a little wonky. I think it's about 6 hours behind Central. And so if you want to say, oh, it's 12. No, actually, I think with the time change, I have to verify this. I might have to verify this next video. With the time change, I think it's to 5 hours because we move the clocks ahead. So 5 hours from Central Time, and you can really go to any other time zone and just add or subtract the hours you need. But 5 hours from Central Time, and so this does not mean midnight on Tuesday. On Wednesday. Actually, you know what? This model is outdated. We are looking at this model now. So this is the Zixu. So this is 1 a.m. basically, valid at 1 a.m. And so it's not 1 a.m. yet, but it's getting very close. And so this is what the model says the weather should look like at 1 a.m. And you can play this, and it's great. And one thing I just want to point out here is, here we go. So there's the frontal boundary that forms. And it seems like they forecast Saturday in the morning, we see that start to especially affect Corpus down here. You guys start getting to Birmingham. Houston's still a little bit okay, but as we speed it up, the front comes down, and what happens is, even though it's kind of hard to visualize here on the model, the front actually kind of sticks around. Weak frontal boundary here, and it becomes stationary. And why that happens is we have a cold air mass that has dived down, and so there's a lot of cold air behind this front. And then you have a warm air mass, probably residing in the Gulf, that's pushing against it, and that's what makes that frontal boundary. You have two air masses, and it becomes a cold front because the cold air mass wins out and starts pushing the warm air mass. And so what happens when the front becomes stationary is the air masses can't push each other. They stay put. And so that usually gives you a lot of just showers and thunderstorms around the area. And that will move out and it will push up as a warm front, especially by the time of next week it's going to be gone, dissipated. And so it'll push up a warm front, which is going to make weather in Corpus and Houston probably warmer. If we go look at the, I just deleted that. If we go look at the forecast, get detailed info, that would probably make it warmer. And as you can see, by Saturday it's 81. If you look at Tuesday, you get a high of 87, and even Monday you get a high of 85. So that warm front is going to warm up our temperatures. So that's kind of cool. I do like looking at that. And we'll get into some. There's a lot of different models you can look at. Snow, not really, because this is Texas, especially in extreme southern Texas. One thing I do want to look at is vorticity and wind. That's pretty interesting. Upper dynamics, that stuff gets a little crazy, so I think I won't exactly get into that until later, especially maybe like the last video, to where I just want to throw that there. And then thermodynamics is another one that's kind of fun to do. It's a 2 meter temperature, not 2 millimeter, 2 meter temperature. So basically surface level temperature. And you'll see that with the surface level temperature, when that front comes through, you will see the air you see like it's like a little defined line there. That's where you can easily see where the front is. And so you see that push down, you get this cold air behind it, warm air in front of it, and you can see that that cold air dissipates pretty quickly. It gets down, it's able to stay there for a second, but it's gone very quickly. And then we have this. I did not look at these models beforehand, so this is actually very interesting how this this cold air is diving in from Canada, and this is not very far out, so this could be very accurate. And this is very cold air. I mean, we're seeing -4 degrees Fahrenheit in Canada. But it looks like that this cold air is going to fizzle out before it can get down here. But that's going to make the north extremely cold, which is unfortunate because I like the cold air. So yeah, that cold air is going to fizzle out, and the heat is going to return down here. It's probably going to be, it's going to be very hot. Okay, so moving on from that, one thing that I really like to, this is going to be the last part of the video, but prog charts are very good tools. and they're not very difficult to explain, especially the surface level prog charts. And they cover the entire United States, so I don't have to look up separate forecasts or separate prog charts. And this is in UTC. UTC is the exact same as Zulu time, so you just subtract 5 if you're in Central time. If you're on the East Coast, subtract 6. If you are in Mountain time, I think you subtract 4. I think that makes sense. And then if you're over here, you subtract 3. So yeah. So Central Time Zone, take 5 off this, and you get your extra time. So not really 3 a.m. More like 11 p.m. the previous day. So looking at this would be valid. So this is when it's valid, and looking at that, so this is about 11 p.m., which it is about 11 p.m. today, and so this is probably really close, because the closer you are to the exact time, the more accurate the forecasts get, and that's when that uncertainty comes in when you speed it up. Now this is very certain when you're only going out maybe a couple days, and here's our front that's dipping down, and you can see all this snow and ice and wintry mix behind it, lagging on behind the front, and the rain in front of it, and that cold air is going to dive in, and you can see North Dakota, South Dakota are really getting the heaviest stuff, especially that ice, which is just really terrible to deal with. Especially like in Texas, we don't want anything to do with that stuff. But yeah, the front continues to dip down, and it starts moving very quickly. And by the morning on Saturday, the front is down here in our neighborhood. But what happens is it's becomes stationary. This denotes a stationary front. Lines like this denote a trough. You can see it down here. They give it to you. Hurricanes, but it's not hurricane season right now. And included, which we saw. Yeah, here we go. Here's not included front. And so another thing that is also shown are dry lines. There are no dry lines on this right now, but a dry line looks like a warm front, except it's pale like a trough. And dry lines usually have very severe storms along the edge. A lot of them, at least in previous experience, really do form up here during the summer in Texas, up near Lubbock and Amarillo, and they push down into the Dallas area and all the areas parallel to that. And you can get some very severe storms along that. Usually they have to issue severe thunderstorm watches and warnings. And one was able to dip down really low, and we got a really severe storm that one night that I can remember. So I really do like severe weather, and we'll talk about that more in the next videos. We'll talk about tornadoes and hurricanes and mesocyclones and supercells. But yeah. So if it comes to stationary front, and this is morning on Sunday, and then it jumps more. This is morning on Monday. We can see that stationary front has turned into a warm front, denoted by these half circles that are red, and pushes up. And this I probably should explain this. This little red line that encompasses this green area means that there is a chance for a thunderstorm. And the light green means that there is a chance for rain. The dark green means that it's likely. Same thing for the snow. The light snow means it's a chance, and the dark. Let me just go back to show you. See this dark blue stuff? That is definitely going to be snow, heavy snow, most likely. Probably a winter advisory needs to be issued for that. And then this lighter blue is just a chance, maybe a 40, 30, or 50. But this is probably 60% and above of a chance. And here we go. See, I knew I missed one. Here's the dry line that I was talking about. You see it has these little half circles, but they're not filled in. And sometimes you get a very severe weather along these things. But on this, it looks like this thing fizzles out. Actually, no, it's kind of lagging behind, but the front is the main contributor here. And so the front is pushing this dry line away, and we just see it disappear and into this trough. And so And so we get the stationary front, and then move it ahead, we get the warm front. And then when you get so far ahead, they can no longer predict with accuracy the weather conditions. So they really just give you the surface symbols: low pressures, high pressures, troughs, fronts. They'll give you hurricane symbols, or tropical storm. And tropical storm is simply just the same thing, but it's not filled in the middle. It has like a little eye. Um, so yeah, tropical storm. I don't know why they don't show that here, but it'd be nice. So that's pretty cool. And looking at the more complicated stuff, you can go into low, and this is really for ceiling visibility, especially for the aviation, especially when you start getting into and then mid. This is where things get wonky, and this will be very fun to explain, and try to make sense of it all. And then you get the high, and yeah, so we'll have fun with this, but we're not gonna. This video is already long enough. One last thing I wanted to talk about was Harvey. Harvey was probably one of the storms that really. There was Hurricane Ike, and when Hurricane Ike came through, I was only about 7, and so Hurricane Ike was kind of a driver, and that's why I've gotten into hurricanes. And so it's very unfortunate I can't record this while hurricane season's happening, because there'd be a lot to talk about. Hurricanes are very, very fascinating, but very destructive. Cost a lot of lives, and that's unfortunate. But he made videos on Harvey, and yeah, he was very busy. Morning videos, evening videos, and so very, very cool to check out this guy's page. During hurricane season, especially if there's a hurricane approaching Texas or any state, that you're worried about, this is a good guy to come to, because he knows what he's talking about. He has a PhD, so I would expect so. And even before he had the PhD, this guy, I mean, he sounds better than some of the people on the Weather Channel, but he breaks it down very well. And what's so interesting is Harvey was not a hurricane at first. Harvey was only a tropical storm out here in the eastern Atlantic. And it had come off as a wave, and it broke apart because of high wind shear. And wind shear, yeah, we'll get into that later. We'll save that for the hurricane episode or whenever I decide to talk about it. But let's just say wind shear is not good for hurricanes. It ripped the tropical storm apart. So Harvey became an open wave, just a disorganized cloud of thunderstorms over the ocean. But then it got over here in the Caribbean, where the shear was lighter. And then it got up here into the Bay of Campeche. It crossed over the Yucatan into the Bay of Campeche, and that's when it underwent rapid intensification around this area. And it was not supposed to be a Category 4 storm. In the original advisory, it was only supposed to be a tropical storm to maybe a Category 1 hurricane, but it underwent rapid intensification as it made its approach. And by the time it was up here, it was already a Cat 2, Cat 3, and it was on track to become a Cat 4, and then it made landfall, and that whole story is there. But Hurricane Harvey was a very interesting storm to me, because of how it was able to stay as an open wave and regenerate itself, and that's why they made sure to monitor that open wave, because you never know when stuff like that can happen, and obviously devastating impacts. One of the most, tied with Katrina for the most costly tropical cyclone in the Atlantic Basin. So a little bit of weather history, but that will do it. I've already talked for, I think, way too long, and so that will be it, and that will complete day 1 for the deal, for the observation. So there we go.